This is lesson 54A, the first of a couple videos on polar coordinates and similar triangles. Now at this point in your math career, you have used what is called rectangular coordinates. Let me throw a picture up here. Okay, so there's your rectangular coordinate system where you have an X and a Y, and you were then instructed to place points on here given coordinates like this. So that means that you went over 3 and up 1, 2, 3, 4, 5 to right there. Okay, and that ended up being the point you were interested in. Alright, there's another way that you can find that same point, and it is called using polar coordinates. And the way that works is we draw a line from the origin to the point we're looking for. Okay? And we label how long that is. So, gosh, I don't know how long it is. I'm just going to make something up. Let's say it's 7 long. Okay. So from this origin, we could have a point that's 7 long anywhere along here. I mean, anywhere we draw a line and the length of it is 7, we have a point on that circle. Well, we need to know exactly which point we're talking about. And in this case, we're talking about that point right there. So the way they determine that point exactly is start here and measure a degree. So let's say that this is 65 degrees. Well, that way we know that the point is 7 units away from the origin, and it is 65 degrees up from the positive side of the x-axis. And instead of labeling that point this way, we would label the length of the line and then the angle we went from the positive side of the x-axis. And that's how we talk about polar form. So the length of that line here, this one that I have labeled 7, this length here is also called the magnitude. And I'm sure I'm not right in saying this. I don't know all the scientific jargon. But this magnitude is pretty much like the strength of the line. Okay? Like if we were pulling a rope here, it would have like 7 pounds of force. Or if I put a 70 there, it would have 70 pounds of force or whatever. But anyway, for right now, we're just going to call it the length of the line. And I'm not really sure why the book is doing this, but I guess every book is going to be different as far as how they label things. So we have to have a certain way of labeling our coordinate system. And right now what we do is we have, let's say, 3, -5. And that's a point that's over 3 and down 5. So what they're going to use in this section is they're going to use R for right and U for up. So this one right here is 3 to the right plus 5 up. Okay, so that -5 there, when you're on that XY axis, if you remember dealing with this, you're going over 3 and down 5. So we went 5 down. Okay, so we didn't go up, we went down, but we're going to use up, and we're going to use the minus here to say the opposite of up. So that's the way they'll write this. So they would write this as 3R minus 5U, because it would be just, we had plus or minus, or plus -5, let's just write it as -5. And that would be a way that we label our points. So in rectangular form, we would write it like this. And in polar form, we would write the strength of that line and then the angle from here all the way around to here. So it might be 310 degrees. And that would be polar, and that would be rectangular form. Now what we're going to do is we're going to switch back and forth between polar form and rectangular. And we use trig functions, sine, cosine, and tangent, in order to do that. In fact, we're just pretty much going to stick with sine and cosine. So let's erase all of this stuff and do a couple of examples here. So let's move this up for right now. Let's leave it here. We might need it. We are going to need it. Alright, so it says in example 54.1, change 4 at 57 degrees. That's the way you say that. The angle, you use the word at. 4 at 57 degrees. And we want to change it to rectangular form. Alright, so that says that there's a line out here that is 4 long, and the angle here is 57 degrees. Alright, so something that you noticed, I hope, is that I drew a triangle. I drew a line that was 4 long, and then I have a triangle here. Let's put the bottom here. And what that does is it gives me an opportunity then to use sine and cosine in order to figure out my adjacent side and my opposite side, because this is my hypotenuse. So if I can find my A, my adjacent side, that's my x, right? So if I'm trying to change this to rectangular, this would be my x, which would be right here, and this would be my y. And that's what I'm looking for. I need to find the A and the O, the adjacent and the opposite, the x and the y, in order to name this using rectangular coordinates, which is what I have right here that I'm erasing. Alright, so how do I do that? Well, the trig function that deals with hypotenuse is sine and cosine. They both deal with hypotenuse. One's opposite over hypotenuse, one's adjacent over hypotenuse, but they both deal with hypotenuse. So the sine of 57 degrees is going to be opposite, or my y value. That doesn't look like a y, does it? My y value over my hypotenuse. My cosine of 57 degrees is going to be my adjacent over hypotenuse, or my x value over my hypotenuse. Okay, so if I'm trying to find y, what do? I multiply both sides by 4. So I have 4 sine of 57, and over here I have 4 cosine of 57. And so 4 cosine of 57 gives me my x, 4 sine of 57 gives me my y, which gives me a formula. If I'm looking for x, that is equal to my hypotenuse times my cosine of theta, whatever my angle is right here. That's what we're going to call theta. My y value is going to be h times the sine of theta. Now notice here, and this is the way I remember this formula, is alphabetically C comes before S and X comes before Y. So the lower letters on the alphabet are together, and then the upper letters in the alphabet are together, and that's just a way to help me remember which is which. Alright, so let me get rid of, I don't know if I can get rid of any of this. Yeah, everything's stuck together, isn't it? Okay, well let me get rid of all of it. Alright, so I said that x equals h hypotenuse cosine of x, which is 4 cosine of 57. So you take your calculator and you put the cosine of 57, then you multiply it by 4. And when you do that, you get, for an x value, 2.16. So that is going to be the length of x, A. Alright, y then is going to be h sine of x, or 4 sine, sorry about that, of 57 degrees. And we take the sine of 57 degrees, multiply that by 4, we get 3.36. So my x value is 2.16, and my y value is 3.36. And this section of the book is going to write that as 2.16 to the right and then 3.36 up. And that is what they're going to use as far as writing it in rectangular form. So this is polar form. That is the conversion to rectangular form. And all you're doing is taking this formula to find x, the hypotenuse times the cosine of, this shouldn't be an x, that should really be a theta, shouldn't it? I don't know why I put an x there. Theta is always the unknown angle. X is always the unknown length. Alright, so anyway, so 4 times the cosine of 57 will give you your x, which is right there. 4 times the sine of 57 will give you a y, which is right there. And it's that easy to convert. Okay, so let's look at the second example and put that on the next video.